We also have triangular prisms. Yes? Correct. So we won't be really touching triangular prisms today. Okay? We'll wait for that a little bit. But today we'll be handling rectangular prisms. Okay, that's more important for us to understand. So today we really need to come. Meanwhile, we'll just finish up with this lesson. My charger is not, my laptop's not working. Okay. Now, if I draw a cube, can you tell me what all is in this cube? Tell me what all do you see in this cube? Rohan. Vertices. Which are the vertices? Can you point them out for me? Yes. Okay. So these are the vertices. Okay. What else do we have in this? Anyone else? Prachi. Faces. So which is a face? This is a face, right? So this is a face. Okay. Right. Anything else? Edges. Which one is an edge? This one's an edge. Okay. Great. What else? Height. What's the height? This. Right? This is the height of the prism. Should be length. This one's the length. Okay. This one's the length. And then breadth. Right? So what we see is from our old 2D images, where we had say a square or a rectangle. Yeah, we just had the length and the breadth. Now we have an additional height. Right? That's how we are creating this three-dimensional object. We now have a height. Now, when we see this is a straight out cutout object. Imagine, remember the example that we had taken? Imagine you have a A4 size sheet, those white blank sheets that we use. Yeah, you take a single sheet and then you keep placing one sheet over the other. Right? You keep placing one sheet over the other. What happens then? You slowly start getting a height of sheets. Right? Now, originally you had just one single sheet, and then what happened? When you placed at least 100 of such sheets on top, you now created a space inside that object, which you can now fill up. Correct? And that's what we associated as volume of a solid. So volume of a solid is a space created when you have two parallel faces coming in and creating a void inside. Right? That's how we created the concept of volume. That's how we understood the concept of volume. And we checked our bottles. So what were the bottles? There were cylindrical, there were circles with a height. Yeah? If you touch your own bottles, you remember? Your bottles of what? Are basically two circles connected in a cylinder. And that creates a three-dimensional object, and you now have water inside. Right? So it's now carrying water. That's volume. Now, suppose it comes to a situation where you have to find the volume. Okay? How would you do that? Simple. We had learned that we could fill this up. Yeah? We could fill this up with smaller cubes. That's something that we had learned previously. Okay? Why? Because what do we call a cube? Why do we call it a cube? Because each edge is of one unit, and that unit could be anything. It could be centimeters, it could be meters, it could be inches, right? It could be anything. Doesn't matter what the unit is, but each side, each edge is of a single unit. Correct? That's why we call a square because every side or every edge is of the same size, and in a cube, every edge is of the same size. Correct? Now, if you have a differentially shaped object, say you have a cuboid, fill it up with smaller cubes, right? And that's how we had started finding out volumes. We filled it up with cubes here, right? On this edge. So how many were there? 1, 2, 3, 4, 5, 6, right? So 6 on the length side, and then we'll fill it up over here as well. So we have 7 on the length and 6 on the bottom, right? So when we fill it up with unit cubes like this, what did we do? We simply multiplied the unit cubes on the base with